Welcome back everybody, and in this video we're going to look at arithmetic series. So an arithmetic series is the sum of an arithmetic sequence, and in this video we're going to look at sort of three parts of this where we have two formulae to sum the arithmetic sequence and also this notation here on the left which is known as sigma. Let's dive in.
Do it.
Okay, I'm going to start just by explaining this term here, sort of this symbol, this sigma. Okay, it basically stands for find the sum of. And here, this UK, if you just think of this as being a general term, like an nth term of a sequence, and it's saying that we have to start from the first term of the sequence and go all the way to n. So let's actually look at an example, and that will probably make it a lot more clearer. If we look at A, so we're going to start from term 1 and we are going to go all the way to term 3, and they've given us the sort of nth term, the general term of the sequence. So what they're really asking us to do is find term 1, term 2 and term 3 and then sum them together. That's what that sigma notation stands for. So when we plug 1 into this, because we see this 1 here, we're going to plug 1 in, we're going to get 4. Now we're going to go and substitute 2 into this, and we're going to get 8. Then we're going to substitute 3 into this and get 12. So we're essentially just summing these together. That's what that sigma notation is. That we're going to add these together, so we're going to get 24. So the answer to this question is just 24. Okay, so on part B, it's asking us to start at term 1 again and go all the way to term 6. So we're adding term 1 all the way up to term 6. So we're going to start by substituting 1 into this, and that will give us 2. And now we're going to substitute 2 in, and that will give us 3, and then 4, and then 5, and then 6, and then 7. Okay, so there are our terms 1 all the way through to term 6. And then when we add those together, we'll just see that the total of this will be 27. So the answer to this question is 27. Okay, let's move on to one of the formulae to sum a arithmetic sequence together. And this is a slightly longer one. Now, if you're doing the IB, this will be given in the formula booklet. Otherwise, you'll need to remember this formula. So let's go ahead and substitute everything in that we see in the question. So it says find the sum of the following. Now, this 4 is going to be the first term. And we also know the number of terms that we're trying to calculate, and that is 50. So that's n is 50. So if we go ahead and substitute this in, just before we do that, we can see that there is a common difference between all of these of 3, right? So there's 3, and it's positive 3. So that'll be important because that's our d value. So let's go ahead and plug this into the formula. So the sum of the first 50 terms is governed by 50 over 2, open brackets 2, times the first term, which is 4, okay, close brackets, and then we have plus n minus 1, so that will be 49 times d, and d was the common difference, so that was 3, close brackets, and if we just go ahead and punch all of that into a calculator,
a few moments later,
3,875. And there's our first example using that formula. Okay, on to our next example. So this time I'm going to use a slightly different formula, and I'll explain my reasoning behind that. So we have find the sum of minus 6 all the way to 141. We know that this is the first term of the sequence, and we can see that the common difference between each term is positive 7. So we have the first term is equaling minus 6, and we also have the common difference between each term being positive 7. Now, there is an issue that we can see that the last term that they want us to calculate to is 141, but we don't know what term number that is. We don't know like how many sort of times that we have gone up to get to 141. So we are missing n. We don't know how many terms there are in the sequence. So that's something we need to address immediately, because regardless of which formula you use, you will always need to know n at some stage. So I'm going to say, using my general term formula, which you can see the link in the description or click the tab above when we did the general term, 141 can be found by taking the first term and then summing n minus 1 d to it, okay? So we will replace the u1 with -6, and that's equal to 141, but we don't know what n is, remember? That's what we're trying to find, but we do know that d is 7. Okay, add 6 to both sides, that's 147. 22 is equal to n. So the number of terms in the sequence is 22. Now, we can just go back up and use that result in the formula. So the sum of 22 terms is equal to 22 over 2, and the first term of the sequence was -6, and the last term of the sequence is 141. That'll be 11 times, okay, 135, and just quickly punching that into my calculator, I will get a result of 1,485, and that is the end of that particular question. Okay, the third and final example that we have here is an arithmetic sequence that has a first term of 8. So u1 is equal to 8, and a common difference of 2. So let's just write those bits of information down. The sum of the terms of the sequence is 170, right? So the sum of terms of the sequence, now they don't say how many terms there are in the sequence. In fact, that's what they're asking you to find here, to find the number of terms in the sequence. So what I'm going to do is just write down that Sn, the sum of the terms, is equal to 170. Now we have a formula for the Sn. That was, remember, there was two different styles of formula that we could use. The sum of the terms can be found by doing n over 2, open brackets, 2 times the first term plus n minus 1 times d, right? And the reason why I'm going to use that is because I know what Sn is, so that's 170. N is what I'm trying to find, so n over 2, but I know the first term, so that's 2 times 8, right? So that's going to be 16, plus n minus 1, and I know d. D was 2, so that's 2 here. Now I've just got to do a little bit of rearranging. Well, but either way, I'm going to get 0 is equal to, now I'm dividing by 2, so it'd be 7n minus 170. So this is a quadratic that I'll need to factorize. So let's go ahead and do that now. So we're going to get n. So we've got two terms that times together to make minus 170. And so that was going to be plus 17 and minus 10. Yeah, okay, there we go. Now, n is either negative 17, which doesn't really make any sense because a term can't be negative. Remember, this is the number of terms, so how can we have a negative? So I'm going to disclude that. Or n is equal to 10, and that is the one I'm interested in, so n is 10. So n has to be positive, so we've answered the question. Find the number of terms of this sequence. Thanks for watching. If you want me to go through more examples, please post the comments below. Don't forget to like and subscribe to the video, and I'll see you next time.